Well, good morning, everybody. It's a pleasure to be here. Thank you for having me. Again, my name is Jeff Erhardt. I lead what we call intelligent systems on behalf of GE. By way of background, I've spent the last 10 years or so building and running two different analytics companies. One was a very broad platform-based analytics company that was subsequently acquired by Microsoft, and then most recently was a machine learning applications company that led to my path here at GE. So it looks like a really interesting agenda that you guys have set up for today. As is well noted, there's a tremendous amount of opportunity and money to be gained in this IoT space. But the question is, how do we start extracting value out of that? So what I wanted to talk about is how we think about that and how we think about applying the field of machine learning and artificial intelligence to this industrial IoT space to start to drive some of these outcomes that were mentioned earlier. So why does it matter? And we saw this a little bit on the other page. But for the industries that we serve as a company, things like transportation, things like power generation, things like healthcare, even very small improvements in productivity can lead to gigantic changes and generation of value. The question and the challenge becomes, though, as we saw, and I think one of the great panels or agenda topics for later on is, this wave of data coming out of these IoT things makes it non-trivial to extract value. So this is a picture quite relevant from down the street here. So one of my colleagues is an astronomer. He studied, I guess, at the competitor down the road. And he likes to tell the story from the Harvard Astronomy Lab in the early or late 19th century, where these were the original computers. And the challenge and the problem became, this worked well when they had analog images, when the data was small. You can have people come in and make decisions based upon that data. But as the amount of data starts to rapidly scale, as we saw in the consumer space and the internet revolution from 10 plus years ago, and now as we're starting to see in the IoT world, we overwhelm the ability of people to make decisions. And that's where the power and the potential of these advanced analytics techniques like machine learning, like artificial intelligence, start to become important. But what becomes really important about those, and we hear a lot of talk about algorithms, we hear a lot of talk about computing power. Those are interesting, and we'll talk a little bit about that, but they don't comprise what we think of as being a true intelligent system as we define here. And especially in the industrial space, where we are dealing with mission-critical, high-risk type of solutions and applications, we need to think about more than just those computational and those algorithmic techniques. And specifically, to tee this up and talk about some of the challenges that we see, I like to think about a complete value chain for how we define and build these intelligent systems. And specifically, if you look at the two things on the left-hand side, the things that we hear a lot about in the news, the things that are happening in a lot of the academic research labs, are things like computational power, distributed computing. Interesting and important, the advances in GPU computing over the past several years. Distributed computing in the cloud, interesting and important. Same thing with some of the algorithmic techniques. The work that's been done to make those more efficient, to more computational, those are good. But over the past couple years, those went from being the bottleneck to now being largely commoditized. And where things are really interesting, and what brought me to GE specifically, was the fact that the forefront of value creation and a lot of the research that's happening now in this space is on the application of those latter two things to the space, i.e. domain knowledge and unique data. And so as I came on board and joined the world's largest industrial company, that was what was really interesting. The ability to take our knowledge and expertise and partner with these people who are healthcare experts, who are aviation experts, and start to tap into these very, very large data sets that have so far been largely unseen by people who have been researching in this space over the past several years. And so what I thought I'd do over the next couple slides is simply share and take a step back from the hype, not talk about autonomous vehicles or not talk about speech recognition, not talk about computer vision, but some of the, what I think of as practical intelligent systems, how we are bringing those to the world, and in particular, some of our guiding principles. The way that we think about and the way that I talk to both my colleagues internally how we think about bringing these to the world, how talk to researchers and academics in terms of how they both teach their people and where some of the frontiers might be that we need addressed, as well as people in the startup space and some of the areas that we haven't yet addressed. So I'll lay those out over the next couple slides and hopefully tee up some and instigate some new ideas for you. So whenever something becomes very popular and kind of hyped, I like to go in the opposite direction. I like to distill things to its essence. And yes, artificial intelligence, machine learning, and if you ask me what is the difference between those, the answer is I don't know, and I don't really care. There's people, again, in the labs down the street or across the street that can go, debate those, and I spend a lot of time at Berkeley, and my colleagues there argue what is the difference between those. I really don't care. But for me, the purpose and the value of machine learning is simply to mimic human decision-making around data-driven workflows. And if you distill it and you think about collecting all this data, like we saw and talked about in the last several pages, having human beings like those women in the astronomy lab that we saw on the first page, making a judgment upon that data, and then driving towards some kind of outcome. There's lots of ways to do that. You can have people look at it and decide it manually. You can start to codify that within a business rule, statistics, a basic analytic. To me, machine learning at its essence is simply inferring the way that those people are making the decisions, augmenting and automating the people, and doing it in a way that continuously gets better over time. And if you apply that lens to it, now think about what we deal with in the industrial space where all these workflows are. People ask, well, where and how should I apply machine learning? The answer is any place you're doing that. And yes, the amount of data may be big, but these workflows, the opportunities, are really in the smaller data space, which is incremental improvements over how things are done. And if we do it incrementally, systematically, in a standardized way, we have the ability to look backwards and say, now we made really big changes. Okay? So what I'll do over the next couple pages is talk about sort of 5 guiding principles for how we think about bringing this to fruition, doing what we just saw on the prior page into this industrial space. Sort of what I've learned, both in the startups that I've run, both in working with, as part of those companies, the vast majority of the Fortune 500. A lot of companies who you think of as being the really data-driven advanced companies, people like Facebook and Morgan Stanley and Goldman Sachs and Pfizer and Merck, but now also internally within GE here. And so to start with, for me, every problem starts with the people. And that if we don't get the people right, everything else doesn't really matter. And so in particular, what's happened over the past 5 years or so is we've entered this era of data science. And what was supposed to be something very concrete, something very specific, i.e. a data scientist being comprised of somebody who has statistical knowledge, who is a computer programmer, and who has domain expertise, has turned into a big muddled mess. And so as part of this, as we take a step back, spend a lot of time thinking about how do we align the right people with the right roles, with the right technologies. And again, no offense to the people who are trying to educate and train the next generation of data scientists, but as we muddle these fields together, and as we try to take people who are trained in one field in business and say, go build software, those things don't always mix. So lesson number 1 is being very crisp about separating and segmenting and getting the right roles and the right people. There is a reason, as somebody I was talking to last night said, that machine learning developers in top companies are paid high 6 and sometimes 7 figures a year. I was on a panel with a guy from Google a couple months ago. He said, if you come out of one of X universities, MIT being one of them, with a PhD in machine learning, you automatically get a 7-figure-a-year salary. No questions asked. Okay? There is a reason for that, and we will not solve it with citizen data scientist tools. So lesson number 1, we got to get the right people right in the right roles. Number 2, unlike the consumer space, industrial systems are high stakes. And that makes us think, and we must think in a different way about how we develop and design these systems in industrial context. And what do I mean? If we think about the consumer space and we think about the applications where machine learning and AI have been widely applied in things like recommendation systems and things like translation starting to happen, voice recognition, et cetera, if we get answers wrong there, it's really not that big of a deal. If Amazon makes me a product recommendation, doesn't quite get it right, I could ignore it. Okay? That's okay. But if I make a recommendation about somebody having cancer or no cancer based upon their radiology image, or about is this jet engine functioning properly or not, it's not might I offend somebody or might they not listen to my recommendation or buy my product, it's will somebody die? And the important point out of this is that the design of these systems becomes very different. And we need to contemplate what it means to be right versus wrong in areas of big data that is noisier and with much lower signal to noise and where the stakes are very high. Okay? So second rule of thumb is we have to design our systems to contemplate exactly that. Third, industrial systems, for the reasons we just talked about, being high stakes, they demand trust. Okay, and what do I mean by trust, and what's one of the most important ways to drive trust? So specifically, we hear a lot of talk, and there's a lot of interest, somewhat justifiably, in autonomy. And people talk about AI as driving autonomous systems. And people talk about going from predictive systems into proactive systems into autonomous systems. And there's some truth in that, and there's some value in that. But we also believe, and we take to heart, that going specifically into autonomous decision-making and taking people out of the loop is not the best way to get there. And so specifically, as we think about building and implementing these systems within GE, we talk very explicitly about a continuous spectrum between human decision-making, augmentation of human decisions, and automation of decisions. And we need to do that, and again, design these systems based on how well we understand our confidence coming out of the machine learning applications that we're building, as well as what's the cost of being wrong. And depending on where we understand and where we rely on those two, we will make decisions about what we allow computers to do versus what we allow people to do. And the point is to help the people become better at their jobs, take the easy stuff off the table, and free up the capacity for people to do what they do uniquely well, which is to solve hard problems, to be creative, and to invent the next new things. Next, in the industrial space, we like to think about machine to machine, wherever it was said, communication. And there is some truth to that. And the IoT space industrial does involve machines, but they also involve people, as we were just talking about. And so the next area that we spend a lot of time thinking about is how do we start to codify and have a set of design principles around intelligent systems that interact with people. So I won't read these through to you, but I'll let you absorb them here. But one of our core beliefs is that very good machine learning systems should start with the end user, how those results are consumed, and work backwards into the math and to the structure of that problem. So we think about things like fault tolerance. We think about things like interpretability. Okay? And those have basis both in what is the end user product design, as well as in some of the areas of research that are now just starting to be tapped into, which is what does it mean to get true interpretability out of these algorithmic techniques, which were historically black boxes with no understandability under the hood. Okay? And finally, what's really important to understand in our space, in the industrial space, is that IoT systems, particularly industrial IoT systems, are physical things. And their behaviors, unlike people behaviors, which are much harder to understand, much harder to codify, it's harder to understand why people make decisions despite all of the studies that have been done. The reality of physical systems is that they can be understood and bounded by physical principles. And so unlike, again, the consumer space where we think about, yes, the reasons why things may not necessarily matter as much, in the physical world, we have to blend very carefully what is our physical understanding based upon the behavior of these systems, the knowledge of how they are designed, and the interplay with the data-driven models. So the next area that we spend a lot of time thinking about is how do we blend physics and data? And we think very specifically about using and understanding our knowledge of how these things were designed, how they were put into the field, how we expect their normal behavior to be bounded. But yet every model, every physical model, is still an imperfect representation of the world. And then how can we capture that imperfect representation, i.e. the error term from that model with these data-driven systems in the sensors that are connected to them, such that they can interplay well together. What's the point? The point is, as we build machine learning, AI, data-driven systems, the computer scientists, the statisticians are really important, but so are the people who understand science, engineering, mechanics. Okay? And getting those two to play together organizationally and technologically is incredibly important to our success within these systems. Okay? And finally, the last one, I said it would be only 5. I added one more in, which is sort of a bonus round. And I didn't fully appreciate this until I came to GE and saw this from the inside, is what it means for these industrial systems to be critical infrastructure. And I call this a bonus one because it's probably the biggest area where I don't think we've solved it and thought enough yet how to address this from a technology perspective. And I know there's some security discussions on later today. Incredibly important, glad to see those. But I'm interested particularly in one of the areas we're spending a lot of time, and I'd love to both see more startups as well as more academic research on thinking about secure and private machine learning in the context of how we manage these mission critical, in many cases, national critical infrastructure type of systems. So I won't dive into these specifically, but I'll tee up a couple things where we're starting to see some research and some interesting stuff start to come out of the labs, because simply saying, no, we're gonna keep the data in one data center on premise in this specific place doesn't solve the problems. And I think people have even seen over the past week or so some of the news of the Russians getting into our power systems, right? That's a big deal. We didn't, vice versa with Stuxnet, et cetera. But unless we solve that, these systems start to break down. Said differently, if we can't get the ability to solve this right, we never harness the power of machine learning to be able to address data large scale aggregated together. Okay? So just to close and wrap up and share a few more sort of provocative thoughts, we've started and held late last year a relatively small workshop for practitioners to think about how do we start addressing some of these things with a bridge between both GE internally, other practitioners in the space, particularly from the consumer side, what they've learned, as well as then academics. And so these were sort of some of the wrap-ups of both the things we've talked about in that workshop and some of the things I've talked about here, about how we think about both the current state of machine learning and AI within the industrial IoT space, as well as some of the challenges that we're facing that haven't yet been addressed. So I'll let you absorb those. I'd love to welcome feedback on those. And in particular, we'll give a little bit of a shout out and keep your eyes open. We'll have a call for papers within the coming weeks for the 2018 version of our industrial machine learning workshop to address some of these and create some more bridges in the space. So thank you very much for having me. Great to be here. Hopefully this kicked off the day, and would love to open it up for some discussion and questions.
So again, give some applause. We really think that interaction, the discussion that we all have, is of value. As my friend Sanjay would say, if you didn't ask a question, it's like you weren't in the room. So I encourage you all to ask questions. I also want to encourage you all to, if you like tweeting, use our hashtag ConnectedThings2018. I know we have, Evan is here doing a lot of tweets. He's got almost 250,000 followers, so thank you for tweeting, and but get it all out there. So Question in the back. I see the first hand in the back, and we'll do about 10 minutes of this.
Yeah, hi, Michael Davies, Endeavor Partners and MIT. I'm curious about one particular thing you said. You put a lot of emphasis on embedding this within existing workflows and keeping the current workflows in place. Some of my experience suggests that if you're actually confronting a more data-driven or evidence-driven process, or you're thinking about using AI, that's actually the point at which you should be thinking really hard about whether or not the current workflows are the right workflows, because otherwise what you're doing is making an existing legacy process more efficient and more effective. And one of the things we found really interesting is using that as a catalyst for triggering changes in the way you do the work.
Yep.
So I'm really interested in your take on
I
that.
completely agree. And so again, maybe we should go write a paper together or something. That's the next area we're starting to think about a lot. So let's parse that a little bit and talk in. So two things. The reason why I say it's existing workflows is we've got tension going in two different directions. So the first reason is, the reason a lot of things in these projects fail is everybody wants to go into a new greenfield opportunity. And as I think will be talked about later today, getting that infrastructure set up, getting the data connected, getting people to understand it, getting people to trust it is really hard. It takes a long time, and the patience, both from a people perspective as well as financial perspective, starts to wear down. So that's why, on the one hand, tension on the other side, think about exactly that. Start with it well, get it standardized, but then in turn, use it as a forcing function to do exactly what you said. And this is what we've really learned and seen over the past several years, is that machine learning has the ability to be a driver of business transformation and business process transformation. And so the question is, how do you bound and how do you balance those two? So the answer is, I agree with you, and one should lead into the other ideally.
On the don't just try and build a greenfield thing from scratch.
Yep.
Because my experience with those is they've been freaking disasters.
Correct.
Because the parent organism rejects them spontaneously.
Correct.
And it's the sort of take the core and figure out how to actually evolve the core.
Exactly.
Okay.
We're going to ask people I know Michelle's standing back with the mic, so if you have questions, he's got a mic. So more questions. Right here.
Hey, Gordon Happ with Red Hat. You were talking about augmentation and autonomy. As we've also seen in the last week or two, there can be issues in that handoff, so to speak. So what are some of your thoughts about that?
Yeah, so I would say two things. So first of all, the fact that there are issues is exactly why it's so hard to get these things right. Understanding the concept of when your system is going to be right or wrong is a non-trivial thing, as well as then understanding what are the bounds around the system design for when you should allow a decision to happen versus not. Probably one of the design principles we put in there for the product designers was thinking about and understanding within your overall system, how do I contemplate for the fact that I need to both explore and exploit, and that my AI portion will deliberately sometimes do things that might expect it to be wrong to optimize as a whole. And so again, the way I think about that and come back to that is, it comes back to algorithms or machine learning not being implementable or not well implemented by itself. It needs to be contemplated as part of the overall system that understands fault tolerance, interpretability, as well as what those proper bounds are.
How about here, and then we'll get to Ken.
Thanks very much for your presentation. Toy Bay, American Tower. You talked about the privacy and security aspects of, and I think it's just a big component of how these next generation technologies will be developed. And I do agree also that the bottleneck or the challenges are sort of the software stack, the encryption and the application layer, to make sure interconnectivity and peering is done in a secure manner. My question is around the infrastructure. Do you see the way the networks are being architected going forward? Does that need to change from a centralized to a decentralized? Specific protocols being put to bear. Maybe the connectivity might be wireline versus wireless, et cetera. Do you have any thoughts in that regard?
Not a lot, to be honest, other than to say this, which is, again, there's a lot of talk about, again, what does it mean to do edge computing, to do fog computing and things like that. I am relatively skeptical, let me say it this differently. Doing proper machine learning, artificial intelligence in the cloud, in an aggregated data environment, is still an incredibly early field. And so the way that I think about your question and how to architect that in the short term is less than what is my distributed computing out there at the edge, but rather what is that connectivity and data transfer from edge into the cloud, and how do I segment the right types of computation and the right types of algorithms to be done in certain places.
Ken, you probably don't need a mic.
Mentor, that's a full-time job. What criteria have you used to select applications, commit the resources?
Yep.
And have there been any positive, unexpected outcomes?
Yeah, absolutely. So I would say a couple things. So, and that's a big part of my job, is evangelizing internally and helping teach people. And again, now being part of a company that just celebrated its 125th anniversary, there are people who have been working in their jobs designing these products and services longer than I've been alive, to be quite honest. And that was, both interesting and stunning, is to help them understand both where this can apply, how to think about it. This is the talk, one of the talks I give internally, but then start to prioritize where do we spend our limited resources. So the way that I think about it is a couple things, is what is the balance between maturity of the data stack and infrastructure, maturity of the business model thinking, and then potential impact to the end customers. So one of the ones that didn't really talk about here is, and I think Salesforce is an interesting example of this with some of the plays that they've done, the acquisition of Relate IQ, et cetera. A different version business model talk that I give is talk about the power of business model transformation and the ability to deliver AI and machine learning on aggregated customer data to deliver outcomes for customers. And I prioritize and I focus those parts of the business who both understand that business model, have the infrastructure in place, and who are forward thinkers about how to deliver this.
Right in the middle.
Technology. I used to run a lot of industrial factories, and one of the things that I saw was a big separation between the operations technology network and the IT network.
Yep.
What you just described actually requires a convergence of those two networks, but there's a lot of concern about security. Do you think industrial companies will make that leap, or do you think they'll really keep that isolated and risk losing the benefit?
I think they have to, and that was sort of the point on my bonus one, number 6, which is if they don't, somebody else will. And so, again, that's not my field and area of expertise. My colleagues, both within GE as well as our other complementary technology providers, are driving that and need to solve those problems. But if, again, the legacy technology providers don't figure that out, somebody else will. So again, as we think about, and I know there's some startups in the room, or people are thinking about startups, as I spend time with our ventures organization, thinking about what types of companies am I interested in funding and potentially acquiring, it's those companies that are thinking about that problem in a slightly different way relative to data acquisition, access, and security, that takes that bridge, proves it right, and then we have the ability to scale that out as a much larger company.
We have time for one more question, and since I saw your hand, why not?
Thank you. Sandra Bear with Civic Smartscapes. I'm curious with a real pragmatic question here, because I'm in marketing innovative technology to cities and city leaders. I'm struggling with sort of the key that sort of unlocks their thinking about investing in machine learning, investing in new technologies. So what do you think is the solution to really influencing their decision to make the investment, their decision to sort of change their way of thinking about how things get done?
Yeah, I mean, the answer may be the time may not be right for them to invest in it from a pure pragmatic standpoint. There's a bit of a life cycle that companies, organizations, enterprises have to go through, simply becoming data-driven and understanding how do I make use of this data. And cities are a great example where simply driving connectivity, aggregation of that data, and the ability to help them understand how to make decisions on top of that with things like basic business rules. Go back to the Harvard lab from 100 years ago. That may be okay for now. And it's not until they start to understand where the power of this is, how they start to make decisions based on this data, that they say, okay, now how can I take it to the next level? It ties back to the discussion we were having before about existing workflows versus new things. And sometimes trying to jump to the end point may not be the right solution. It's something we think about every day with our own customers.
That was the last question. Again, let's thank Jeff.
Thank you.
Thank you.